Hi everyone, so this is just a video to help you with test validation. So when testing validation rules, if they work or not, we need to test with different values to see what the different results will be, and this is all part of a test plan. So the type of test data is normal, abnormal, and extreme. So for the normal, you have something that's valid or acceptable data. Abnormal is something erroneous, invalid data, and extreme. So it's usually if you have a value between 5 and 20, 5 and 20 would be extreme values because it will pass the validation rule because it's on the boundary of acceptable data. So it's within the boundary. So 5 and 20 will be extreme types of test data, and anything between 5 and 20 would be normal. So it will just be normal and it will be valid or accepted. So you will test different types of inputs and then you will have to say what type of data you're testing. So 10 is between 5 and 20, so it's normal. We expect it to have an accepted result. 5 is on the very border. It's between 5 and 20. It's on the 5, so it will be accepted, but it's an extreme type of test data. 20 is the same, it's extreme, but it's the upper extreme, and it will also be accepted. Now we get values that are incorrect, and this is something we need to think about. So 3 is a whole number, yes, but it's not between 5 and 20. So it's going to be abnormal, and we're going to get an error message. Minus 10, 10 is between 5 and 20, but minus 10 is less than 5. So again, abnormal. ABC, this is a text, and we need a whole number between 5 and 20. So again, abnormal, and we get an error message. 10.5, 10.5 is between 5 and 20, yes, but it is not a whole number. So we will get an error message. So this is test validation using the type of test data like this. And they want you, for this practical activity 8.32, we have to generate test data that will test the following rules. Okay, we're going to test all of these rules. So what I would suggest is open Excel for practical activity 8.32. They say we should use a table with 3 columns. Test data value. So test data value. Type of test data, and expected result. Okay, and we just beautify this, professionalize. Okay, we just put them as headings. So we have a table. We can even put in some shading. Let me just get to the right the right place. Our shading we can just do here. Sorry. We can make it nice and blue, and we're going to test 4 different types. So 1, 2, 3, 4. So this is going to be part of all of our tests. So we can just put in all borders. These ones, just get borders around. Okay, and what I would do is I would just copy this. How many times? 1, 2, 3, 4, 5. Just so that we have each sheet. Okay, we have 5 sheets. And now the type of data that we need to test for, so what we're testing, is input value is a whole number less than 1,000. Whole number less than 1,000. Okay, so let's first see if we can find something that is normal. So any whole number less than 1,000. Okay, 100. 100 is a whole number and it's less than 1,000. Perfect. Type of test data. We have 3 of these options: normal, abnormal, or extreme. So this is normal, and the expected result is accepted. Okay, let's try abnormal. So what is not a whole number that's less than 1,000? So let's try 500 8.25, so that we have a decimal. This is abnormal. It's abnormal, and it's going to be error message for the expected result. Let's try another abnormal one, that because we have to do 4 tests, that is a whole number, but it's not less than 1,000. Let's make a whole number that's 5,000. So it's abnormal, and we get an error message. And the last one is the extreme. So I know I want to have extreme. So if it's less than 1,000, then we put in the 1,000. So, and it is accepted. Because a whole number less than 1,000, we are going to put in the validation rule as the maximum is 1,000. So it will allow it, because it's an extreme type of test data. So it will work. So what I want you to do is, I want you to do this for sheet 1, 2, 3, and 4 for all of these different rules over here. So this is how you'll do practical activity 8.32.